We're starting to see this pattern emerge of how companies are rolling out AI agents within their business. And generally, it boils down to something that looks like this. We have maybe employees logging into some platform where they can start initiating agents to do some task, or there's an autonomous agent that's being triggered based on some event, for example, receiving an email or a support ticket. These agents are then being spun up in some environment. This could be something that's a managed service, could be running inside of a cluster, it could be something that's just running locally in the machine, and that agent is given some sort of task context. The problems then become is what this agent then can access. So without any controls in place, they could go out to the internet and go and fetch all sorts of things. You might provision them to go and connect to a particular LLM, which may or may not be the right one given the particular task. You maybe don't want an Opus model if it's doing some very basic analysis of some data. And then there's a number of MCP servers that teams and employees are setting up and integrating in order to do their job. So there might be your CRM MCP server, there might be a support ticket MCP server, there might be an MCP server to send emails. And in this untrusted view, we now have a problem when it comes to security. There's no audit trail of what these actions and these agents taken by these actions taken by these agents have done. There's no governance around, okay, which actions can these particular agents do or what data access does it have. There's no control. There's no way to put policy around what these agents can actually do inside of the system natively. And ultimately, there's no kill switch. If one of these goes rogue, how do you go about shutting it down? How do you go preventing it? The model that's emerged is around putting an AI gateway essentially in front of the agent itself. So what that looks like is same setup as before, but now firstly your agents are in a sandbox environment. They actually have their outbound access completely blocked unless necessary. There's numerous sandbox providers. You could do it just a simple local Docker connector on an isolated network, or you can go and use one of the managed services. But there's still context. But now all connections out of that sandbox go via some sort of AI gateway. So Agent Gateway is a CNCF project, LiteLLM is another popular one, but there's also these managed gateways provided by a number of different providers. And then this acts as the front door for getting access for that agent to the outside world. It becomes a routing layer to which LLM the particular agent can access. It becomes the gateway to all the different MCP servers that it could be connected to. And this is where Cerbos comes in. Cerbos integrates into that AI gateway layer and becomes the authorization guardrails, the decisioning point for can this identity, and this could be the agent identity itself, it could be the on behalf of identity coming from the user invocation, it could be down to things like the workload identity if you use something like Spiffy to give the agent identity itself. This is very kind of a pluggable interface. Using Cerbos Synapse, we can go and retrieve the context of the task being performed. So this particular agent is only operating on a customer support ticket 123. We're going to make sure via policy that all the actions performed are scoped to that. Synapse can also go and retrieve further context from other different parts of the system and also make a decision on every connection to the LLM and every connection and every tool call that goes to the MCP server underneath. And all this can be versioned and managed through Cerbos Hub as the control plane for the policy, as well as that unified audit trail of all the decisions that are being made across the different layers. So what does this look like in practice? Here we have Cerbos Support, which is our agentic support ticketing system inside of our enterprise. And in here, we've logged in as a user. I'm currently logged in as Alice. I'm a tier 1 support agent. And when I log into the system, we have a number of tickets, and these tickets have actually already been run through and prioritized by our autonomous agent. So I can go in here, we have this urgent refund request. Our triage agent has been completely autonomously run through and determined this is a high priority ticket. And we can actually go and look at the underlying logs. So when this agent started up, it was given an identity. We then determined based on policy which MCP servers it should connect to. So based on its identity, we're allowing it to connect to the tickets and the CRM service, but we're not allowing it to touch payments or payroll, for example. And then it's gone through and it's read the ticket, it's used the customer CRM read tool from the CRM server, it's then invoked the ticket set priority, and then driven an update. And we can actually go and look into Cerbos Hub and we can see sure enough, there's the tickets MCP server. This is from the automation server support agent, which is the one we just saw. We have some context around which agent harness, which version, which model it's using, and then the actual tickets associated with. So we're enriching this with context from the system itself. And we can see here it tried to do the set priority task tool call, and that was allowed by our policy that we've defined for that particular system. So we're allowing the automation agent to set priority, but we're not, for example, allowing it to go and refund the customer. If I now go and invoke the refund handler agent as myself, so I've now delegated, me as Alice, delegated an agent to go and do a refund based upon the context and ticket. In this case, we're getting a different set. So our policy is now allowed three of the MCP servers to be connected. So we're giving it tickets, payments, and CRM, but our policy doesn't allow payroll, for example. And then we can see there's tasks going on. And here we have an example of it's determined that we need to issue a refund, but based on the context of the ticket, this was a request to do a refund of $99,000, sorry, $9,000, and that's actually been denied. We have a policy that says if you're a tier one support agent, you can only refund up to a certain limit. That deny has been caught at the gateway, the MCP server tool has been rejected, and thus the rest of the flow runs, and the agent has decided to go and update the ticket. And we can see here, unable to process refund due to tier limitations, go and contact a tier two agent for support. If we come into our audit logs, filtered by myself, we can indeed see the refund request coming through. So now here's my refund handler, and it's acting on behalf of myself as Alice, the user, and therefore it's been denied by our policy. And we can actually come in and see our policies that led to this inside of our policy store. We have our payment policy, and for the payment policy, we have numerous checks, and ultimately we want to see the refund cap. And sure enough, the refund is denied if you're a tier one support agent and the amount is over $50 in this case. And we return not only the denied decision, but context to then feed back into the LLM and to the agent why that was denied. One simple use case of how this works, there's a number of different areas around how we can protect other systems, we can provide insights, we can guide and protect from drift, and prevent further escalation of agents behaving. But it's all driven by this unified architecture that's controlling not only model access, but also MCP tool access, and with Synapse now as the authorization guardrail determining for every call to an LLM and every MCP server tool having policy around what's allowed and denied and giving them that unified view, and then also that control point of what your agents do to prevent the drifting of task. And we can plug into your existing ecosystem of agent sandboxes, AI gateways, MCP servers, without having to go and reinvent any components or rebuild any of your architecture.